Hello friends, this video on Unit and Measurement Part 2 is brought to you by examfear.com. No more fear from exams. Please watch Unit and Measurement Part 1 before going ahead with Part 2. Okay, so now we will study about length measurement. How do we normally measure length? Normally, the range of the length which we see around us, that falls under this range, that is 10 to the power minus 3 to 10 to the power 2 meters. So this range length, that means any length that falls within this range, is generally measured using a meter scale, which we normally see in our labs and around us. Now for lengths which is outside this range, that means for lengths greater than 10 to the power 2 meter, we use a method called parallax method. We will discuss this in detail. That means for very huge lengths, we use parallax method. Now similarly, for extremely small lengths, that is below the range of 10 to the power minus 3, we use methods like electron microscope or tunneling microscopy. Example of very small lengths, we would say maybe the example we can consider is, if I ask you to estimate the size of a molecule. Size of a molecule is so small that you cannot even see it with your naked eye. So to measure the size of a molecule, you can definitely not use a meter scale. So for that we use even the normal microscopes which we use, even they don't have that much of resolution. So for such small lengths, we generally use special microscopes, that is the electron microscopes or sometimes the tunneling microscopes. So these are just the methods which we use to measure lengths of different ranges. So now we would discuss the parallax method in detail. What is parallax method? Now, before we discuss what is this method all about, we should first know what is the meaning of the word parallax. The effect whereby position or direction of an object appears to differ when viewed from different positions. When I say parallax, it means that we are viewing the same object but from two different positions. The best example to understand this is, you close your left eye. Let us suppose you have some object. Say you have a candle which is quite far from you. Not very far, but at some distance from where you are standing. You first close your right eye and view the candle with your left eye. Then you open your right eye and close your left eye and try to view the same candle which is located at the same position. You will find that there is a change in position. Just try this as I keep saying. Close your right eye. Try to view an object which is at some distance from where you are. Then try to view the same object closing your left eye, and you would see that there is a slight change in the position of the object which you are viewing. Why did this happen? This is because you observed the same object from two different positions. So the distance between these two different observation points is known as the basis. And this phenomenon is known as parallax. So in our example, the distance between the left eye and the right eye is the basis. This distance. So distance between your left eye and right eye is basis. And the phenomenon that when you close your left eye, you can see the object position slightly changed, as when you close your right eye, this entire phenomenon is referred to as parallax. So what is parallax? The effect whereby the position or direction of an object appears to differ when viewed from different positions. So, I hope this is clear to you now that what is parallax and what is basis. So now we will take an example and we will try to see how do we apply the parallax method. Let us suppose Ronnie is standing here and he wants to estimate the distance of the tree which is very far away from him. Now it is not possible to measure this distance using a meter scale because this distance is greater than 100 meters. So, we will employ parallax method here and we will do the same experiment as I told you before. So, what would Ronnie do first? First of all, he would observe it closing his left eye. Then he would observe it closing his right eye. So let us suppose this is the position of his right eye and this is the position of his left eye. So in the first, now before we start, I already told the distance between the two eyes, that is your basis. So we denote basis as small b. So this is your b. Now, you want to measure the distance of the tree from Ronnie. Now, let us suppose the angle which the 2 points of observation subtend at the tree is this theta. Right? And let us say this distance is d. Okay, so we'll have the sketch here so that it becomes easy for you to understand. So this is the basis because this is the distance between the left eye and the right eye. This angle is theta and this distance is d. Now, we know that this d is very greater than this small b. The distance between the two eyes is very small when compared to the distance of the tree from Ronnie. That means this b is very less than d. So, or we can say that b by d is very less than 1. So, we can say that theta, the angle theta which is subtended here is an extremely small angle. Correct? Now, what we can consider is, let us suppose that this is the center of a circle. This point O is the center of a circle and this D is the radius of the circle and this LR is an arc of the circle. We can assume. So, what do we assume here? We assume that O is the center, D is the radius and LR is the arc length of a circle. You can imagine this to be a circle somewhat like this. Correct? Okay. So, now with these assumptions, we can write that theta is equal to LR by D, that is equal to B by D. And from this, we can write that capital D is equal to B by theta. Now, using this relation, we can determine the value of capital D. Right? So, what did we observe here? In the entire experiment, we observed that a tree was located far from this guy Ronnie. Now what we did, he first closed his left eye and observed the tree by his right eye. Then he closed his right eye and observed the tree with his left eye. Now you would ask me, practically, how will you determine the angle theta? How is it possible to practically determine the angle theta? While you are closing your left eye and observing the tree by your right eye, you can just measure this angle using a protractor. Similarly, you can measure this angle using a protractor, and using simple maths, you can find out this angle theta. Right? So once you know the basis and the theta, you can very easily calculate the distance of the tree from Ronnie. So that is how we apply parallax method for calculations of distant objects' distances. We will see another example here. Now let us suppose we have to find the distance of a distant planet from Earth. So this is the Earth and this is a distant planet. So we want to find the distance between this Earth and the distant planet. So even here what we do, we observe the planet from Earth from two different observation points. Let us say we take one observation point as A, the other observation point as B. Now we observe the planet from these 2 points. Since the object is very far off, so this object can be treated as a small point. And the distance between the points A and B is what we have defined as basis. So this is our basis, and in this case, this basis is nothing but the diameter of the Earth. So B is the diameter of Earth. Right? And in this case, if we know the angle, that is the angle subtended at this planet from both the observation points, then we can find out the value of D. So even here D would be equal to B by theta. So this relation will be helpful in finding the distances of distant objects. We will take examples of the same. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.